Here's a big load of trig identities and a couple of trig integrals at the bottom, which is kind of handy to know. Now, so look at this one. Suppose you wanted to do the integral of 3 tan squared. Now, there's 2 main strategies. Kind of always has been 2 main strategies. And those are, some people coming in there. And those are use identities from here to change it into something that we can integrate or do a use of, or more than likely do both things. Well, I don't know the integral of tan squared. I do know the integral of secant squared, but, right? I know that one. That's integral of secant squared is tan. I don't know the integral of tan squared. Well, I could turn tan into sine over cosine. You'll just have to trust me, it doesn't work. Is there anything else I can turn tan squared into?
Secant squared, take away 1.
Now, the advantage of doing that is I can integrate secant squared minus 1. Because isn't the integral of secant squared tan, and the integral of the number -1 is negative x plus 1.
What happened to the 3?
Oh, it's still there. How about this one? Let me tell you right now, this is a trick question.
Isn't that just a secant x?
Right, so 2 of them just gets you 2 secants. The antiderivative of secant tan is secant, because the derivative of secant is secant tan. Remember the two-way street idea? How about this one? Whoops. This one's a use of. What use of do you think might work here?
Secant.
Correct. Why? What made you think secant?
Get rid of.
Right, these earphones are really bad, so I got you got rid of. You may have finished the sentence, but I never heard it.
I think you get rid of the tan.
Okay.
I guess. This one.
Yeah. Okay, we are going to have to just, I hope you can hear me better than I can hear you, but at least it's better than nothing. So I will fill in what I think you said. You said something like you got rid of the tan. Oh, that's what you said. So if you differentiate secant, you get secant tan. You do the crossover, you get secant tan dx. You then do the isolate part. That's what dx gets you. And this fella is 5 tan x secant 5x, and then replace the dx with the secant x tan x du. Now, what you might have noticed that is not typical is that I did not turn that into u to the 5. Hold on to it just for one extra line, right? Do not change them. Leave them alone. Replace the dx, that's okay, but leave these alone. And the reason I want you to do that is that in these kinds of questions, the cancelling is a little bit different. You see how the tans cancel? You see that secant takes care of one of these secants. And now I have 5 secant to the 4x du. And now I can do that guy. Now, if I did it too early, what would happen is I'd have a secant x kind of hanging out there like a poor little orphan, and you might not know what to do with it. So in these types of questions, it's just a good idea when secants and tans are involved for you to leave the original question, to only replace the dx, do the cancelling, and then when it's whatever it is that's left is left, then go changing everything into, in this case, u to the 4s. Well, this guy is a power rule, and then convert back. Is that okay? Are we good with that? Okay. So let's move on. All sorts of weird ones floating around. Which one's my next one? Here's one. The minute I do that box, you know it's going to be a U sub. I just did that one, didn't I? I did. Sorry about that. At least I did a version of that one. Let's do that one then. It's a U sub. Which U sub?
Secant.
And correct. That will definitely work. Why?
You can pull a tangent and a secant out on the equation and make a secant tan.
And that's
And
great. Well, and why is that a good thing?
if you have a tangent squared left, you can turn it into secant take away 1.
Yes, secant squared. Yes. So let's see how this works out. I'll leave these guys alone for a few moments. So I get this guy. I still have this guy. This fella becomes 1 over secant tangent du. I'll cancel the secant. I'll have a tan squared, and I'll have a du. And we know that guy is okay, because he's u. And just like you said, can't that guy be turned into this guy? So what I now have is a u cubed, a u squared take away 1 du. Is that basically what you were thinking about, James? So do you see that you're going to be playing with identities? When you do secant tans, the identities that you tend to play about, I mean, sometimes you might do that one, but most of the time it's going to be these two guys, right? And the u subs are pretty straightforward. A single secant or a single tan. Now, sometimes it's less obvious which one it is, right? For instance, if I chosen tan here, right, I could have chosen a u sub a tan. What would the derivative of tan be?
Secant squared.
And you know that one also would have worked eventually. So it can be the case that the secant and or the tan, both u subs will work. In some circumstances, only one of them will work. If you pick the wrong one, hopefully you'll know after a couple of lines that there's this bit left over that you can't get rid of. You know, like you've done a u sub a secant and there's a tan cube left over. That's bad news, right? Or you've done a tan and there's a single secant left over, or a secant cubed or a secant 5. It's always the odd powers that are bad. Even powers you can fix, right? A secant squared can be turned into a version of tan squared. A tan squared can be turned into a version of secant squared, right? So it's okay to have even powers of the other thing left over. You can fix that. You just can't have odd powers of the other thing left over. Are we cool so far? Right. I had a list here, but I think I'm kind of making a meal of it for myself. What's left here? Not too much. I got one down here. Why did I put that one in? I'll write it down and maybe it will remind me why I chose this one. Oh, by the way, I've added that the integral of a secant is this guy and the integral of a tangent is this guy. Just in case you end up doing a u sub and there's a little secant left over or a single tan left over, right? I could imagine that might happen sometimes. This guy is a u sub. I just need to know which one to pick, secant or tan. It's always a secant or a tan, right?
Secant.
Now, if I do a secant, it's going to use up one of these tans, isn't it? And a secant.
Okay.
No, that's not bad. And isn't that going to leave maybe a tan squared?
Yeah. But
And
it's all
can-
about the secant 5. Oh, never mind.
Yeah, the secant 5 is fine, right? That's going to be u5.
Yeah.
So secant x would certainly work. Could the alternate tan x work? Well, if you differentiate a tan, don't you get a secant squared? So it'll use up 2 of these guys. That means I'm going to have a secant 4 left. Well, secant 4 is kind of awkward. If it isn't a secant 4, just a secant squared squared, in which case I could do this, and that would work. Both of these would work. But one of them is a lot less work than the other. Right? One of these is a lot less work than the other. Which u sub do you think just ends up being less what to do.
Tangent.
No, actually, I would disagree. No. I'm going to do mine and we'll see if I'm right. Oops. If you differentiate this guy, you get a secant tan. If you do the old crossover stuff, you get a secant tan dx, and then you isolate. Then remember to keep everything, everything as is for a little while. There's a tan cubed. There's a secant 6. Instead of the dx, I get this guy. What we got out of this was one of these secants gets killed off and one of these tangents gets killed off. So I'm now left with the tangent squared, that guy, the u. So since I'm choosing secant as my u sub, that guy's going to turn into u to the 5 and I'm happy. Tan squared is not any good to me, but tan squared can be turned into secant squared minus 1. Now everybody gets turned into u's, which is exactly what we need, right? Pretty close to being done. So what do we do next?
Distribute.
I think one of the themes, for want of a better word, is that when you do trig identities, don't you tend to end up with polynomials in U? And that's kind of what happens, right? You just end up with polynomials in U. And this guy would be 1/8 u to the 8 take away 1/6 u to the 6, I'd say. And then return to sequence. And that would be finished. Now, one of the things that I've avoided even yesterday, and I've definitely avoided it today, is that I've been doing the ones where it's plus C, but there's quite a lot of questions where these actually are numbers. So I guess I should at least talk a little bit about how you would do that. Suppose this was 0. And suppose this was pi over 4, right, for example. Exactly the same math. The difference would be here. What you would have instead is a pretty messy calculation. You'd have this fella, take away this fella, evaluated at x equals 0 and x equals pi upon 4. That means we need to know what the secant of pi upon 4 is, and we need to know the exact value of the secant of 0. Now hopefully you've got your old unit circle handy. There's pi upon 4, happens to be root over 2, comma root over 2, right, that guy? You can use that to find secants. You just have to remember there isn't a secant the same thing as 1 over a cosine. So we know what cosines are. And then don't you just take the answer to a cosine, and because it's 1 over it, you flip it upside down. So that guy's root 2 over 2, so when you turn them upside down, you get 2 over root 2. This guy is 1 over a cosine of 0. Well, isn't the cosine of 0 1? So 1 over 1 is just 1. So far, so good. Now, this guy here, you could tidy him up now, but it's probably going to sort itself out later anyway. But you're going to raise it to the 8th power, which is pretty messy, and you're going to raise it to the 6th power. The 1's going to be easy. That's just going to be an 8 take away 6, and you know, dot dot subtract dot dot dot, and you get the usual ugly. This answer here's probably got a lot of root 2's in it, but it'll be an answer that is an exact value. Do not go and tell me it's 0.1234. Whatever sign will also tell you that you're wrong. The only time you would do an answer that has limits of integration as this does is if they say give the answer to 2 decimal places. Then you can do your calculator and just give me a decimal estimate. So I haven't actually done much of that, but you got to just be good at your unit circle. So along with a guy that looks something like this, shouldn't you probably have a little unit circle fella for the questions where you need to do exact values of sine, cosine, and secant and tan. Any questions so far? Are we good? I guess silence is a good thing. Just having a quick look at what's left. This one is a version of question 14. I guess the question is, what on earth do we do with this guy? Because he's not your usual sine cubed tan squared kind of thing, right? Those tend to be u-subs, right? We've done a few of those. This 1 minus tan squared might have been nice if it was in here and could be written as something else, but it's not. So I'm not going to do that. But I do need a strategy.
Do you change the tangent squared to secant squared minus 1?
Okay. Can I just stick that 3 outside the integral? It's, for some reason it's bugging me. So what do you have? 1 take away this. Well, 1 take away this gets you 2. Take away this guy over this guy. Okay. That's got some mileage. I need to keep going. What do I do next? Don't go thinking u-subs or anything. I'm talking about changing this into something else. That's what I'm thinking.
You turn both the secant squares of x into 1 plus tangent squared of x.
That would be a cyclic thing. You just end up with pretty much the same guy you started with, but with a 1 plus tan squared in the bottom. So if you've turned something from a tan into a secant, it's probably never going to be useful to do the secant back into the tan, right? It just won't help. But it was a good thought, and nothing wrong with that. Think something else. Go. Forget identities for a second and think something else.
Oh, split them up to, so it's 2 over secant squared x minus secant squared x over secant squared x, which is minus 1.
Agreed? Now that's better. Well, it's really good for this guy. It's not so good for this guy, but we can work on this, right? We can work on this. So far, so good. Anything you can think about that would help with this stuff? This is the second last question. The one after this is going to be even worse. But got a roadblock. I got 2 over secant squared. Not a U sub in the world's going to save it. Turn it into tan squared, even worse. I'm limited options. What can I do?
You pull out 2.
Okay. I'm still going to be left with 1 over secant squared, so what do I do now? I don't want to tell you, because if I tell you, you'll all go, oh, okay. But if you fight through it and you figure it out yourself, it's going to stick in your head better. So I think this is a homework question that is driving you crazy, and you're trying to figure out what the heck to do with it, because that's the problem. What do you do with this secant squared in the bottom? There must be something.
Could you write it as 1 over cosine squared?
Okay. Which is good. Put a little bracket around it. Isn't 2 over 1 over cos squared the same thing as 2 cos squared? I mean, this thing is fighting us, but we're getting there. Do you recognize that we can deal with cos squared? Isn't there something I can turn cos squared in that allows me to get to a place where I can eventually actually integrate? What's cos squared equal to?
There's the half angle identity.
So it's a half, 1 plus the cosine of 2x. Take away 1, dx. That 2 times a half cancels out, so basically I'm left with this guy. Oh, wait a minute. Are you telling me that that entire thing that we started with is just cosine of 2x? That is a surprise, isn't it? Remember what it started life off as? And after fighting through all sorts of do this and do that, we've got this. Well, I know how to integrate that. Isn't the answer the sine of 2x with a half? So I'm getting 3 halves plus c. You might not feel comfortable, or you might not even like identities. But that saved your bacon, knowing that you could change something into something else, and then do something else, and then maybe even do something else after that. But eventually, it became something you could integrate. And your goal is always to take ugly guy and turn them into something that you can integrate. And we don't really have many things that we can integrate. So our goal at the end, in this question at least, was to do that. Kind of cool? Got your brain going? Right, there's only one last question, and then we can do a little taster on the next guy. Before I do that question directly, what color am I using? Using this one. If I asked you to do this guy, I hope you would say, it's this half thing. So it's the integral of 1/2 1 minus cosine of 2x dx. And that would be the integral of a half, take away a half, the cosine of 2x. And then you'd get power rule, antiderivative of cosine, and that's A. Comfortable with the sine squared? Could do a similar looking thing with cos squared? Sure we are. Oh, I better start a new piece of paper. I'm going to have to do, in the last question, we're going to have to find a version of him. Okay? A version of him. So let's make that our challenge. There's not a U sub in the world that's going to save you. This is going to be trig identities for a while. And then when we're finished, we'll be able to do some integration. Any suggestions about how to split this guy up so that it'll get us closer to what we need?
Could you write sine of x squared and that whole thing squared?
And the answer is yes. Is there something that we could do with sine squared that is going to help us? Now, I know the temptation is to do 1 minus cos squared, but can I tell you that in this particular question, that's not going to work? I mean, in some cases it will, but not this one. So look for something different than turning this into 1 minus cos squared. What could you turn sine squared into if you can't change it into 1 minus cos squared?
1/2 times 1 minus cosine of 2x.
We're good? Now, all I'm going to do here is distribute this thing. And it does mean I've got some messy fractions. But we're now there. So what I'm going to do next is FOIL this out. And that's going to get me a quarter. Then I'm going to end up with negative a half the cosine of 2x. And then I'm going to be left with plus 1/4 cos squared 2x. And we're now there. Okay. Good to go. I can integrate him. Good to go. I can integrate him. Problem. I need to figure out what to do with this guy. Now, over here, I don't have anything with 2 x's in it. But I don't want you to think of that as anything special. I want you to think of these thetas as being placeholders, right? Things you can put x into, but you can also put 2x and 10x into it if you feel like it. So can't cos squared be written as a half 1 plus the cosine of 2 theta, right? Now, if theta happens to be 2x, I can still use this. I just adapt. So what's the adaptation going to be? It's going to be a half 1 plus the cosine of how many x now?
4.
Then continuing with our process, I now have this fella. That times that is an 8, and 8 times 1 gets me an 8, and an 8th of a cosine gets me this guy. What I'm now looking at is that guy and that guy, I believe, is 3/8. Take away 1/2 of a cosine of 2x plus 1/8 of a cosine of 4x dx. At this point here, can't we integrate? And I don't need a u sub. I just integrate the usual way. Are we okay with that question? The approach that we did to get sine to the 4th power into a format that we can now integrate. And I thought we might get started on the next thing, but I didn't realise it would take me so long. But we do have enough time to finish question 15, or at least a version of it. Y is going to equal 3 times sine squared x. Y is going to be 0. X is going to be from 0 to pi. We're going to rotate. Yes, it's one of those questions about the x-axis. Now, you just trust me on this. I know that looks like sine x, but it's also what 3 sine squared x looks like. And this is 0, and this is pi, and this is going to be the axis of rotation. Right. So if you were going to do this, I suggest strongly that you use the disk method, which means that the volume is going to be the integral from 0 to pi of pi f of x squared dx. Basically, f of x is the radius. So that's going to be pi, the integral from 0 to pi of sine squared x squared. Isn't sine squared x squared that fella? And haven't we just
Isn't
spent?
it 3 sine squared x?
Correct. So let me stick that guy out. And haven't we done this guy already? Which is what all this was about. So I'm just going to write down the answer that we got earlier. And it's a bit messy. It had a 3/8 and take away 1/2 cosine of 2x and add 1/8 the cosine of 4x dx. So just try and remember that 9 pi, something, take away something, right? Right, it's going to be 3/8. Take away. What's the cosine of 2 pi? What number is the cosine of 2 pi?
1.
Right, so that's going to be take away 1/2 then, and that's going to be plus an 8, right? And this fella is going to be what? 3/8. What's this guy going to be? Something not right here. 0.
Have we ever found the actual integral?
So again, kind of breaking up.
I don't think we found the actual integral of it. Like, we just got to the end of this this problem. So
Oh, that explains it. Thank you. That's why it's not working. Here it goes. It's 9 pi antiderivative. Right, so the antiderivative of this guy is 3x. Take away 1/4 the sine of 2x. Add 1/32, and the cosine, that becomes the sine of 4x. There we go. And I'm going to short time, it doesn't help me at all. Okay, so it's going to be 9 pi. Plug pi in here, you get 3x pi. Isn't the sine of 2 pi, 4 pi, 6 pi, 8 pi 0? So those two are zeros. Right, so take away 0 plus a 0 minus, when you plug in 0, 0, 0, 0, that whole mess is 0. So all we're left with is 9 pi times 3x pi, which is 27/8 pi squared, which is actually the right answer, so everything's cool. Right, the reason why I was hesitating here was I was going to get the answer 0. Right, if I'd used the numbers before, because I hadn't integrated them. And my brain was saying, you can't get a volume of 0. I've screwed up. And thankfully somebody noticed that the screw up was, I hadn't taken the antiderivative yet. So this shape, rotated about the x-axis, has a volume of 27/8 pi squared. Will you now say hi for attendance? And we have covered, I guess that's a much more natural place to finish. That's us covered the first 2 sections. So you should be able to hopefully complete all those guys by Sunday, so that when I see you on Monday, you're ready for the last topics in this chapter. Did we learn some cool stuff today? Did you like my joke about the Scotsman with a gun, Emma?
Oh yeah.
James, you going to put any comment on my joke about the gun? You can't think. I know what's going on. Your mum has brought you up really well. If you can't say anything nice about something, don't say anything at all. Is that what you were thinking?
Yeah, my mom told me if I had nothing nice to say, don't say anything at all. And then there's
That
just
is,
people who wonder why I'm so quiet around them.
oh, if I ever meet your parents, I am going to tell them that. You are in some deep doo-doo. You are in trouble, young man. Yeah, so if I see your mum walking by or anything, I'm going to shout, hey, can I talk to you for a minute? Now you're worried, right? Douglas, you'll be my backup. He did say that, didn't he? Right?
I'll be the witness.
You'll be the witness. You'll have to go into witness protection, James. That's what you're going to have to do. You're going to have to leave the state.
Well, I know a few lawyers.
Okay, don't tell me one of your parents is a lawyer.
My brother's going for law, so.
Okay. Well, that depends if he wants to defend you or not. He may decide to go on his parents' side.
Yeah, I may have to get another lawyer.
Okay, guys, have a nice weekend. As I say, you've got enough. Homework's pretty heavy duty, so I really do suggest strongly that you get them done by Sunday, so that you've got the decks cleared for next week, because we've got some more, believe it or not, even more heavy duty stuff to come next week.